Good afternoon, and thank you for joining the ACS International Center on today's webinar, Global Scientific Collaboration, a Key to Scientific Success. I'm Christopher Leprad, and I'm with the ACS Office of International Activities and the ACS International Center. I'm joined today by Dr. Joe Francisco, past ACS President and Dean of the College of Arts and Sciences at the University of Nebraska-Lincoln. And I'm also joined by Mac Mikolzaka-Smith at the University of Chicago and author of the 2014 paper, The Scientific Impact of Nations, which is a topic of today's webinar. Dr. Francisco, if I could go ahead and have you jump in here.
Thank you, Chris. I want to thank everyone for joining us today to talk about global scientific collaborations. This is such an important topic for those in the scientific community, and particularly those of us in the chemistry community today, because as the world becomes closely connected and chemical enterprise become more global, there are really many opportunities for our community and students and faculty and researchers from the many domains of our community, i.e. Government laboratories, industries, and universities, to become engaged globally. I'll tell you a little bit, about myself. And I was president of American Chemical Society in 2010, and in the 2010, that was a very interesting time in the presidency, where I introduced the importance of global collaborations and also global education for chemists in our community. And so I'm really excited today about the topic, and particularly the new findings by Matt Smith from the University of Chicago, who's actually done some real scholarly work digging into the details of the benefits of global collaborations. If I move to the next slide. So Matt is going to, has done some beautiful work looking at scientific collaborations of nations and their actual benefit and towards enhancing productivity, as well as enhancing one's connectivity as well. If I can go to the next slide. And I just want to really talk about why I see that as being very, very important. In 2010, I convened a task force and actually a little bit of a town hall meeting where we brought industry, academia together around the table to discuss what are the needs of our community in terms of being able to prepare members of our community to be able to work within the global collaborative space. We started that conversation from the perspective of curricula, if there are any particular needs in the curricula. We also started that conversation, from the standpoint of what did the industry find as important needs, and how we as educators could actually better equip our students and members of our community to be able to move smoothly within the global collaborative and global space that we're all working into. And I want to encourage you to go back to CNE News article back in 2010, I think that was in April, to look at that. That, of course, then led to some important developments because as we started to listen to industry, start listening to students and what they're finding, we start to see more of an importance of, at least in the chemist, needing to operate within that global context. We also found that many of the students and many researchers here at home and abroad as well were looking for, opportunities as well. But then that question was really, are many of our people here at home, are they really ready, and what does it take for them to be prepared to take advantage of the opportunities within the global space? Of course, that led to us responding to that need in organizing and setting up the ACS International Center. And of course, the leader of that initiative, Judy Benham, who's actually shown on this slide, a lot of thanks goes to her for really spearheading this on through and responding to the needs of the community, responding to the needs of industry, and making sure that we have members of the chemistry community being prepared, being ready to operate on the global context. Let me just tell you why we see and some of the data that really points to that need. We'll articulate that on the next slide. This is some data that was provided by Lisa Freehill in 2010. Actually, when I was giving a talk at the National Science Foundation, and she was curious about the expressed need of the community about international collaborations and opportunities that need to be better prepared to take advantage of those opportunities that are emerging and growing in the global arena. And while I was talking about that, she actually mined the database at NSF. And so she looked at two interesting data sets. She was looking at the data set for all scientists who are involved in collaborations, in the U.S., who, of course, have NSF funding. And as you can see in this slide, in terms of the business arena, there are more scientists and working in that arena that are engaged in international collaborations. And of course, the least engaged in global collaborations along educational institutions. And this is for all scientists in that NSF database. When she mined that data specifically for chemists, and that would be on the next slide, what she found, which was, I thought, pretty astonishing, that those in the business industry arena, significantly more engaged. And she actually broke that data down into women and females and males. And you can see in industry, both females and males are highly engaged in international collaborations. That's the way, when we talk about global chemical industry, they are connected, and anyone moving into that arena need to really be prepared to, function and work collaborative with other branches and other companies as well. What she found in terms of government laboratories, about 25 to 27, but astonishingly, when we look at the academic sector, and this involves four-year colleges, universities, they're the least engaged in international collaborations. About 13% of the women are, and about 23% of the men, as compared to over 40% of men and women in business and industry are connected in global collaborations. I find this is very, very interesting, because in actually academic institutions, we're really training the next generation to move into that space. And so the question is, how do we help students and our postdocs and even young faculty to be more engaged in global international collaborations within the academic enterprise? Where do we see really the value added? Clearly there's value added if many of the students move into business because they're expected to operate in that space. So what can we bring to the table to really help everyone to be better prepared, i.e. their readiness to engage in international global collaborations? Next one. So I was really delighted with the research and the findings that Matt did because he really brought to the table very convincingly with actual data the real impact and the real benefits of global collaborations. And so, Matt, I'd like to turn it over to you, give you that opportunity to now start to tell us of some of the exciting findings of your work.
Great. Thanks so much, Joe, for that introduction, and thanks, Christopher, for bringing us all together here today to talk about this important topic. Today I'm going to be talking about a paper that we published in PLOS One last year looking at the role of international collaboration on scientific success. So I know there's a lot of contention about what scientific success might actually mean, and we'll definitely touch on that later in the presentation because it's really parsing this kind of ambiguous success into concrete quantitative measures that was also a central goal of our paper. So without further ado, we live in an extremely interconnected world. So this is just a map of scientific collaborations across the world. And it's this increasing internationalization of science has done a lot of good. It's spurred a lot of innovation. And in more recent times, it's spurred an investigation into what the effects of this collaboration have had on science, both in terms of comparing productivity between countries and looking at measures of productivity of single countries. And this was one of the major sources of inspiration for our study. Another source of inspiration came from a paper that we discovered published in Psychology back in 1982. And in this study, the authors Peters and Cecchi took papers published by big names, top universities in psychology journals. They took these papers and they changed the names and affiliations of the authors, and then they just resubmitted them to the exact same journals that they were originally published in. And the response they got was unanimous, rejection. So the most common justification for these rejections, methodological problems. So affiliations really matter in publishing as much as we would prefer them not to. And we kind of were ruminating over this and this increasing internationalization, and we came up with two questions that we really wanted to answer. First, does the number of countries represented in a paper's author list as some kind of proxy for internationalization, does that predict publication performance? And then second, does it matter which countries those are? Thinking back to Peters and Cecchi, do certain countries have a bigger impact than other countries? So, and to get at these questions, we needed to collect a lot of data. We needed to cast a very broad net. And so what we did is we collected just over 1 million article records from Scopus.com for subject-specific journals. So this means not Nature, not Science. These are journals that primarily publish only in a specific discipline, and we covered 8 different disciplines. And then for each article, we collected various bits of information about the article itself, such as the date it was published, the number of authors, etc., as well as information about its publication outlet, so which journal it got into, what the impact factor of that journal was. One important detail here is that the way we treated countries in the affiliations was quite different from previous studies that sought to answer similar questions, and that's, well, in previous studies, international papers would either be assigned to each country in its affiliations, either as a wholly to each one or maybe split in some way between the countries and the affiliations. We instead treated each unique combination of countries as a unique category. So a collaboration between the United States and Canada would be in a separate category than the United States or Canada by itself. And this really allowed us to look at the differential effects of specific collaborations in a very unique way. So in addition to the Peters and Cecchi paper I mentioned earlier, we were inspired by some of the foundational studies on national scientific output. May in 1997, King in 2004, and then also some recent studies on the importance of international collaboration and international science, which was called The Fourth Age of Research by Adams in his 2013 comment in Nature. So though these provided a great foundation, we still felt like there was some room for refinement in the analyses. So this figure was taken from the King article referenced on the previous slide, and it's somewhat representative of the way people thought about national scientific output. The basic idea is you look at the proportion. In this case, they looked at the ratio of two proportions, but you look at a ratio or the proportion of papers published by a given country or a group of countries in a given year out of all of the papers published in that year. And you compare that to the proportion of total citations in that year out of all of the citations in a given year. And the logic is if the country produces a higher proportion of papers than the proportion of citations it receives, then it's not doing so well. And if it's getting more citations than papers it's publishing, then it's doing quite well. Put simply, in this graph, is the pink line above the blue line, or is the blue line above the pink line? But when we were thinking about this framework, we felt like it was conflating two measures of success. So there's the success in the terms of which journal you get your paper published into, and then there's success in terms of the number of citations you receive once it's published. And of course, this isn't quite right because these aren't independent. So what we really want to know is the number of citations you will receive. What we really mean is how many citations will you receive given the paper that you publish into, given the journal that you are getting your paper published into. So relative to, and not just within the journal, so what we want is we want relative to its peer publications, so which for our intents and purposes means it was published in the same journal and the year. These two questions then describe the two components of scientific success as we see it. So we called this journal placement, for which journal did your papers get into, and citation performance, for how many citations does your paper receive relative to its peers. These concepts might be a little bit clearer in some later figures. Don't feel too bad if this is still fuzzy. We'll definitely come back to it. But for now, just keep these two concepts in mind. So what did we actually do? These are just some highlights of the analysis we performed. We binned the data. This would just to reduce some of the effects of small differences, and maybe impact factor is receiving a lot of heat lately. If you bin it, it reduces the effects of small changes in that. We used two different models to account for, to try and model the data. So we used a more traditional linear model, and we also used a proportional odds model, which is a little bit better at dealing with non-parametric or ordered data. We used AIC, which is a model selection technique to make sure that the things we were including in the model actually made a difference. And finally, we looked at some maybe mechanistic explanations for the differences we observed. I won't be talking about this last point in the presentation today, but it is in the paper if you're interested. So now on to what you've all been waiting for, some results. As a heads up, the general format for the next several slides will be I'll show you a figure, a subset of the figure first, just to explain the details of what you're looking at. Then I'll show you the whole figure, explain that, and give some short takeaway message for each figure. Before I get into the first figure, though, I'm just going to orient those of you who aren't used to looking at cumulative distribution functions. which is the first figure we're going to talk about. So the x-axis on these plots will be a ranking, either journal placement or citation performance. So Tier 5 is the worst, and Tier 1 is the best. And the y-axis will be the proportion of papers in that tier or worse. So the first step as we go along the x-axis is the proportion in Tier 5. The next step adds the proportion in Tier 4 to those in Tier 5, and so on until you get to the best tier, Tier 1, at which point all of the probabilities should reach, all the proportions should reach 1, because that includes all of the possible tiers that you could be assigned to. If your line is low and to the right, that means that more of your papers are in higher tiers, so you're doing well. If your paper is high and to the left, that means more of the papers are in the low tiers, and you're not doing quite as well. So let's look at some real data. These are the results for analytical chemistry. Remember the x-axis, each paper was assigned a journal tier for the graph on the left and a citation tier in the graph on the right. The journal tier is based on the journal's impact factor, the journal into which you've published, and the citation tier is based on how the number of citations that paper receives compares to the rest of the papers published in that same journal and year. Looking at citations first, we can see there's this really clear hierarchy where more countries is better performance. So remember, again, this corresponds to the lines for fewer countries being above those for more countries. So you can see that goes in pretty orderly 1 to 5 at each tier. But we don't see the same unanimity in the journal effects for analytical chemistry. So what's going on here? Essentially, the benefit for having more countries in analytical chemistry comes at this citation stage where we see the effect, and less so at the journal stage. We're not quite sure why this is the case, but it could have something to do with how narrowly the impact factors are distributed in analytical chemistry journals, which is to say that analytical chemistry journals are fairly similar in their benefits. Looking at some other fields here, here we have condensed matter physics on the left and ecology on the right. We see the same trend present as we saw for the citations in chemistry, both fields and in both metrics. So more countries do better than fewer countries in all cases. And it's interesting here to look at the differences between the fields as well. So we see in terms of journals, physics and ecology are quite similar. However, while there's almost no variation between the country counts for physics journals, we continue to see a benefit when we move to citations in ecology. So this suggests that in condensed matter physics, it's nearly the opposite of chemistry here, where the performance of papers is nearly deterministically set by which journals you get into, and there's not very much variation in citation counts once you get into a specific journal and year. So overall, what these figures suggest is that though there's some variation in where this benefit is coming into play, international collaboration in general produces more successful papers in regards to both the journals you get into and the citations that you get thereafter. So having addressed this most basic question regarding the raw number of countries present in the affiliation list, we next turned to look at that second question, the identities of those countries, and asked whether or not certain countries or combinations of countries have a disproportionately beneficial or detrimental effect. In these results for analytical chemistry, we can see that there are clear differences between individual countries. Singapore does very well on the right, and Ukraine does quite poorly on the left. But we also see a bit of an echo here from the previous results, in that combinations of countries, and sorry for background information, these are simply the top 50 most prolific countries or combinations of countries. So those with the most papers in our data set. But these combinations of countries we see in this graph tend to do worse than their composite countries. So if we look at the U.S. and Japan combination does much worse than the U.S. does or than Japan does. But then there are also some exceptions to this, in which, for example, the United States-China collaboration does better than China, though worse than the U.S. The more common result across all fields is more so like these, which are the results for citation performance in analytical chemistry. And again, we see individual variation, but more interestingly, what we see is that there's variation in how combinations of countries perform. So in some cases, they do better than either of their composite countries, Japan and China, for example, on this plot. In other cases, they do worse. For example, the U.S. and Japan in this plot. And then in many cases, it does somewhere between the two. Again, United States and China being a good example. So this is maybe what we would expect, this intermediate effect where you kind of average the benefits of either country. But it's interesting to see that in some cases you do worse, and especially interesting in the cases where you do much better if you collaborate. And that's actually a much stronger trend in the other fields we looked at, that they're doing better than either of the composites. And the takeaway here in any case is that the countries may differ in their, they do differ in their success rates, both in journal placement and citation performance. But combinations of countries can be tricky. In some cases, they do better. In some cases, doing worse than you'd expect by just a linear combination of their scores. Looking at those previous figures, we realized that many of the countries that did well in journal placement also did well in citation performance. And likewise, those that did poorly in one did so in the other. To get at the relationship between these two metrics, we just plotted the rank from the previous figure. So from best to worst and from best to worst in each metric. And we plotted those ranks against each other for each country and country combination. So as you can see here for analytical chemistry, most of the countries fall pretty close to the one-to-one line. That is, their performance in either of these metrics is fairly similar. But more interestingly, there are some countries that fall very far from this line. For example, Pakistan, Turkey, and Iran in the lower right corner. These countries are doing really well in citation performance, but they're doing quite poorly in journal placement. They publish in worse journals than you'd expect, even though their papers are then overperforming compared to the other papers in those journals. And these discrepancies are very interesting. They could have a variety of explanations, but there were two that we found especially convincing. And those are academic climate and bias. So for the former, one might imagine that if publishing in quote-unquote good journals is somehow separated from career advancement or prestige, then there's less incentive to go through the extra effort of publishing in a top-tier journal. And even if you have a good paper, you might just publish it in a lower impact factor journal because it's easier. And then you get this effect of really good papers in not so good journals. Alternatively, this could be a result of bias. So even though papers are really good, reviewers or editors are rejecting them because they come from an undesirable country. And this would have the same effect, though with a little bit more nefarious reasoning behind it. In looking at other fields again, in the results for physics, we see some countries having the opposite trend. They get into good journals, but then they don't do so well once they're there. And this could also, again, indicate a culture, maybe a culture of always shooting for the top. So if you submit every paper to the top journal, regardless of its quality, you're going to eventually get some in just by blind luck. But that won't make them good journals. That won't make them good papers, just getting into good journals. And so they won't do so well in citation performance. Or again, due to bias, this paper isn't very good, but it's coming from country X, so I'm just going to publish it anyway. In ecology, again, we see that the trend is much stronger, and most countries fall fairly close to the one-to-one line. But this is all to say, most countries perform pretty similarly in journal placement and citation performance, but it's really these discrepancies in this trend that are most interesting, and they can be used to identify potential biases or maybe just differences in academic culture. The final thing we did is a modification of that very first figure I showed back at the beginning of the talk from King's paper. And so here we still have the proportion of papers, this time in red, and so that is, again, out of all of the papers published in analytical chemistry in 1996, the U.S. published about 20% of them. And the proportion of citations is now in orange. So out of all citations received in 1996, about 25% of them went to U.S. papers. But what we've added here now is this expected proportion of citations in black and a confidence interval around it in blue. So to reinterpret journal placement and citation performance in light of this figure, we have journal placement as the discrepancy between the red line of the papers and the black line of expected citations. If you publish in good journals, the black line will be above the red line. That is, you expect to get more citations than average. And if you publish in poor journals, the black line will fall below the red line. You expect to get fewer citations than you would if you published in average journals. And similarly, citation performance is the discrepancy between the orange citation line and this new expected citations black line. You either get more or less citations than you would expect based on your citation what you would expect based on the journals you publish into. So you can look at this across fields and across countries. Here I'm just showing the most prolific countries for analytical chemistry, the top 4. And we can see some overall trends. So we see an increase in proportions of papers published in China at the expense of more established Western countries such as the United States and Japan. But I think it's a little bit more interesting to consider some of the subtleties as well, such as the fact that China has gone from underperforming in both journal placement and citation performance to overperforming in both in just 15 years in analytical chemistry. And while the U.S. continues to publish in good journals in analytical chemistry, it has also begun to underperform with regards to citation performance in recent years. So the orange line has dropped below the black line in more recent years. An overall trend across all of this data is that the proportion of citations tends to fall within this expected range. So you can see some good examples here with, for example, Spain or condensed matter physics in more recent years. What this is indicating is this, again, that the determinant of publication success is coming very early in the publication process. It's coming at the journal acceptance itself. And what is important about this is that this decision, the journal placement, is decided at the hands of relatively few people. So while citation performance can be influenced by basically any scientist who reads and then cites this paper, journal placement depends only on the editor and the reviewers who decide whether or not your paper is going to get into that journal or not. And I think that this asymmetry between the number of people involved in making the decision and then the importance and the effect, the size of the effect that this will have on you, warrants some further and very careful thought. So I apologize, there's a lot of information in those figures, and I went through them rather fast. But I think one of the most important takeaways here is that journal placement is a pretty good predictor of overall performance. And again, it's exceptions of this rule that end up being the most interesting cases. So just in summary, what does all this mean? Well, international collaborations are beneficial. They're usually beneficial both in getting into good journals and in getting citations thereafter. And I don't think this is a coincidence. There are many possible mechanisms acting behind this. Two that I point out here are increased visibility. So as authors in different places share their research with different groups of people, it can broaden the awareness of your results amongst different circles. And then the second is a potential for increased generality. So this might be most clear with an example from my own field, ecology. So maybe a study of a forest in the United States wouldn't be especially impactful, but if you then compare that forest in the United States to forests across the globe, you can both ask and answer much broader questions and produce more general results that will then impact more people. And this would also increase the quality of the publication. As a final point, getting into good journals does pay off. In some cases, it's almost all that matters. But the current publication process and the ways in which we rank journals are also definitely imperfect. And we need to be careful not to succumb to biases in this scientific endeavor that we're all taking part in. We have a lot of plans for future work in this area, from looking at more closely at the effects of passing time on papers and citations to increasing resolution from whole countries to just universities. But I think in the interest of time, we're just going to pass over this right now, and I'm going to thank all of you for tuning in. This paper was definitely not my work alone. I couldn't have done it without my co-authors, Stefano, Cody, and Emilio, and of course funding both through the University of Chicago and NSF.
Matt, thank you. Thank you so much, for giving the audience and a big picture overview of the importance of global collaborations and the findings of the real benefits of global collaborations. Along this theme, the upcoming ACS national meeting in Denver, there's going to be a special symposium continuing the conversations about international collaborations and the benefits. This symposium is titled The Transnational Practice of Chemistry and Allied Sciences and Engineering Study, Research, Careers Without Boundaries. We have just a number of experts from industry, academia, and government to really start providing their perspectives on global readiness and for everybody in the chemical sciences. So if you're attending the ACS meeting in Denver, I want to really encourage you to stop in and hear some of the real informative talks and meet some of the important individuals who are really having an impact in this space. And now I would like to turn this back over to Christopher to tell us a little bit about what's going on at the ACS International Center.
Absolutely, Joe. Thank you very much. And Matt, thank you for kind of diving into the world of global scientific collaboration and kind of looking at a deeper look at journal citation and performance across the fields. We do appreciate your work in this. I'm going to talk just a moment about the ACS International Center. The ACS International Center is an initiative that began in late 2012, and it serves as a sort of hub or clearinghouse of over 600 opportunities, scholarships, internships, and travel awards for the international STEM community. Of course, there's a big focus on chemistry and engineering, but we have a lot more. We're much more diverse than that. The International Center also provides sort of like insider tips on upcoming calls or proposals. We talk a little bit about eligibility and deadline extensions for that as well. And we also provide various tips on how to go abroad or how to be prepared for a global science career. This webinar itself is actually brought to you by the International Center, and so we do partner with local embassies in Washington, D.C. to talk about potential collaborative activities and with other international organizations through the International Center Affiliate Program. The International Center is actually divided up into two search methods. One, you can browse by location. So we have over 16 regions. So the United States is one, India is one, for example. We have programs in Germany and France and Brazil, South Africa, Singapore, and many more. We also have a section on global, so where that perhaps that opportunity can take you anywhere in the world. And then we also have an area for you to browse by experience level. So whether you're an undergraduate chemistry student who's just starting his or her career, or you're a senior scientist, researcher looking for perhaps a new angle or a new opportunity, we give you that availability and that opportunity to do some research there. And as you can see, we can also browse a little bit deeper by location. We have these countries and regions are focused, but we have many more. The International Center is located at www.acs.org/IC. And of course, you can follow us on Twitter at the American Chemical Society Twitter handle. And also you can watch our archive of webinars or other resources that we have. And of course, if you have any questions about today's webinar or about International Center opportunities in general, you can always email ic@acs.org. I just want to thank you all for tuning in today, and thank you very much to Joe and to Matt for their expertise and their time in helping to organize this. And if you do have questions about today's webinar, please email us at ic@acs.org, and we'll be posting them online to make sure that everybody can benefit from that. And once again, thank you all very much for your time, and we look forward to having you in future webinars.